In this tutorial we'll cover the basics of blueprint interfaces, how they are used and when to use them. Interfaces are just like classes except that they don't have any implementation in their functions and they cannot contain variables. They only contain function signatures. An interface creates a contract. It guarantees that an object that implements the interface will have the functions it describes. This is useful for creating objects that have the same types of functionality but are implemented in different ways. So I'm just going to start by creating our blueprint interface. I'm going to right click and find blueprint interface, and I'm just going to call it explosive object, and I'm going to open it up here. So this is the default view for an interface, a blueprint interface. It automatically creates you a new function. But as you can see, you can't edit the function graph at all. As I explained earlier, the interface only contains function signatures. So I'm just going to rename this function and I'm going to call it explode. And I'm going to give it an output variable of Boolean type has exploded. And then we can compile and save that. Interfaces with no output variables creates just simple event calls. However, an interface function with an output variable, like I've just added here, creates a dedicated function with a return node, as you can see. So I'm just going to close that. And what we're going to do is we're going to create a series of actors that will explode on impact in different ways. So I'm just going to create a new blueprint actor class, and I'm going to call it blueprint explosion pad. And I'm going to open that up here. I'm going to add a new scene component, call it root. Make it the default. And I'm going to add, what do I want to add? A cylinder. Just call it pad. Oops. Going to make it just a little bit smaller. Maybe a little bit. And I'm going to make this a trigger. And I'm going to call the onBegin overlap event. So this is where when our cubes that, or our objects that implement our interface are going to receive the call to their function that's going to cause them to explode. So what we need to do is we need to take our other actor that overlaps the pad, and we're going to call the does implement interface node, and that returns a Boolean telling us if this actor implements the selected interface that we want to look for. And we want to look for our explosive object interface that we created earlier. So we want to then create a branch for that, hook that up, and now if it evaluates to true, we can call our explode interface function that we defined earlier in our interface. Because if this evaluates to true, we know that it implements our interface and then that this function exists on the object. So we can call that after our branch. And there we go. So any actor that implements our interface, when it overlaps our explosion pad, it will call this function. So let's close that pad. I can add it to our scene. And if we play here, you'll see that because the player doesn't implement our interface, it's not calling our function and it's not doing anything. So let's create an actor that implements our interface and give it some basic logic. So I'm going to create a new blueprint actor. I'm going to call it blueprint explosive cube. Going to open that up. Going to give it a new scene component, call it root, set it to the default. I'm going to give it a new cube component and just call it cube. Going to compile that, and in our event graph, this is where we will implement our function. But first we need to add the interface. So if you come to class settings, you'll see there's a little component here on the right hand side that says interfaces. You've got the currently implemented interfaces for this object and the inherited interfaces. Now because this isn't a child object of any other actor, it's not going to inherit any interfaces. So we're just going to add a new interface, and we want to add our explosive object interface. And when we do that, you'll see that on the left hand side, the function that we defined in our interface has now appeared, and we can set some logic in this function. So what do we want to do for when our cube explodes? At the moment, for some basic sort of logic, we just want to destroy our actor just to see how the relationship works. And we can compile that. Now, first we probably should set physics to simulate and compile again. So now if we add this to our scene and set it up just above our explosive cube, so when I play, it's going to drop and it's going to hit our explosive cube. Our explosive cube pad will call the interface event on our explosive cube. So it's going to call this function, and this is going to execute. And it disappeared. It destroyed the actor, just as we described, just right here. So what can we do with this? We can extend this so that any actor that implements our interface and then collides with our explosion pad can execute any sort of logic that it wants. But it's best to stick with the theme of the name of the interface. So if I create a new blueprint class of type actor, call it blueprint explosive replicating cube, give it a new scene component, a new cube component, set it to simulate physics, and then in the class settings need to give it our explosive object interface. Now let's do something interesting here. I'm going to create a new for loop, and we're going to iterate from 0 to 5. I'm going to create a new actor, spawn actor from class, and that actor is going to be our replicating cube again. Now I'm going to split our spawn transform. I'm going to get our actor location, get actor location, plug that in there. Actually, no, we might want to just split that, and we will add, let's add 100 to that, just so that we're a little bit above our original point. Now over on our spawn actor, I'm going to call add impulse. So this is going to add a physics impulse to our cube component, and we need to feed it an impulse location, and I'm just going to give it vector up, get up vector. And then when the function is completed, it's going to return true. And I'm going to compile that. Now I've already added the explosive replicating cube to the scene, and a new pad for it to interact with. So when I play, it will explode into many cubes, and these cubes themselves can also explode. So here we have two separate actors that both implement the same interface, that have different functionality but can interact with the same object here. And we can add as many of these as we want. And you can keep on going, adding different actors. So I can add a explosive sphere. And as long as it implements our explosive object interface, it will always receive the explode function call when we hit that explosive pad. So add sound. How do we play sound at location? What sort of sound? We'll just add the first person firing sound, and we will call get actor location. And we will also destroy our actor. So drag our new explosive sphere, and it should play our sound for us. Oops, we need to add it as a physics component. Simulate physics, and I'm going to make it the default root component. There we go. So all of these actors share the same interface but have different implementations for the function logic